Welcome back. In this video, we are going to learn dependency inversion principle, that is DIP. So, the dependency inversion principle DIP is one of the solid principles in software design. It states that high level modules, that is business logic, should not depend on low level modules, that is specific implementation or details. What should depend on abstractions, that is interfaces or abstract classes. Furthermore, abstractions should not depend on the details. Details should not depend on the abstractions. So a little bit tricky, and we are going to understand this with example. DIP promotes a decoupled and flexible architecture, allowing changes in low-level details without affecting the high-level modules. Abstractions act as a contracts that both high-level and low-level modules are there too. So let's understand with C++ example. Switchable. Switchable is an abstraction representing a contract for devices that can be turned on and turned off. So here we have one interface, that is switchable, which is abstraction representing a switchable device. Light bulb and fan are low level modules that implement the switchable interface. So we have light bulb function here and fan function, which is inheriting switchable class and implemented the methods turn on and turn off, turn on and turn off. So we can turn on the fan light. So light bulb turn on, we are going to print this in from this method, and we can turn off it. So light bulb is turned off, we have return method here. Okay, then we have for fan we have functions fan turn on, fan turn off, and we are just inheriting the switchable class here. Okay, then we have remote control is high level module. Okay, we have remote control, which is high level module. Okay, this is remote control, and it depends on switchable abstraction. It depends on switchable abstraction. We have created object of switchable, okay, device here. Yeah, instances of light bulb and file are injected into remote control. We are going to inject, what we are going to inject, instances of light bulb and fan. The instances of class light bulb and file we are going to inject in remote control class. Let's understand this. We are creating instances for low level modules, that is light bulb, we have object light. Then for fan we have object fan. Then we are creating instances of high level modules with dependency injection. Here we are creating object for remote control class, but for in first class we are passing object of light, then we are passing object of fan. So this is how it's going to manage the low level to high level objects. And here we are going to print the from device. Here we are passing, let's assume we have passed light bulb here. So the dev will take light bulb, and this device object will call turn on function from light bulb, then press off function means turn off function from light bulb. When we pass fan object into this remote control method, then we are going to call turn on from this fan and turn off from fan. Let's try with its solution or its results. I have clicked on local Windows debugger. Let's see the results. It's running successfully, and we can see we have called the function for remote for light, then remote for fan, and we can see the result. Light bulb is turned on, light bulb is turned off, fan turn on, fan turn off. So this is how it works, and it's really amazing. Dependency inversion principle. If you have any queries, you can ask in question section. That's it for this video. Thank you.